Good afternoon, everyone. How are we doing this rainy season? How's the rainy season going with you there?
Yeah, fine.
I hope it's allowing you catch your breath. Okay, today I'm a little excited about today's session because at least with all the good news flying around with WAEC saying that they are ready to conduct exams. Actually, very very encouraging. Okay, so I hope that excites you because for me it's very exciting. I don't really. For me, I don't know if it is very exciting, but at least it's exciting when I remember that you guys will have to finish up what you have already started. You know, so that's for me. That's the exciting part. But the other sides of the whole paparazzi is a it's also interesting to note because you can't continue to be at the same level every time. You know, you guys have been trained to want to always give your best. You know, and not the rest of it. So today we are going to do something very very interesting. Okay, so I don't know how much time we have to be waiting for other students to come online. I don't know how you have been doing your own. Uh, Today, have you invited your friends? So coming into this lesson today is quite unique. I don't want to say it's first in history or first time in a long time. You know that I tried to. Yeah, I don't know how long I was looking forward to this qualitative analysis, but I think I always know that it is one area that is very interesting. Let me just share my own experience a little. When I was in secondary school those days, I didn't know anything about qualitative analysis. In fact, I never even knew there used to be anything called test of anions and cations until until the week to WAEC. Let me use that word. So, those days in government school now. So, I hope it's not the same experience that you're having now. Those days in government school, you hardly do practicals, and only for you to get to WAEC and maybe that week of WAEC where there is specimen, they will now start hearing blue precipitate. Those days, I actually got to know was we were start doing revision to us like then my guys came out and said there is specimen for chemistry. They now said there is test of quantitative analysis and there's going to be, and I saw the table. That's my own experience anyway. And I saw the table and perhaps they believe that that is what was going to come out in the exam. So that's why I say I studied the table. For me, I don't just know. I can't remember what I wrote, but the long story is that I got a B3 in that chemistry. Maybe the answers were correct, sha. I don't know. But I shall know that I just copied the table, and maybe by the time I was doing the magic, I was doing the exam hall, I was sure writing what I knew. I can't just remember, but I shall know that that was how I got to know that there was something like qualitative analysis. So if that is your own experience, man, you need to, well, I don't have to say you need to thank God for today's session, but I know it may not really be some of, I know I have some interesting set of students nowadays. In fact, from SS1 now, the students are being introduced to these things, and it's not really difficult. So it's just for you to have a clear mindset that it's the same chemistry that you have been doing all this while. It's not different from the chemistry of the chemistry that you have been doing in the past. Yeah. So okay. So without wasting much of your time, we'll quickly run into the business of the day. Nifemi. Okay. So I think we have some participants who have joined. So please, when you join, always ensure you join with your audio. And then sometimes network can be very, very interesting. Okay, so but no big deal. So today I've decided to simplify it for those of you that are my students. I don't know if you've ever seen this kind of note before, but let's roll with it. So that's the advantage of coming for this kind of session. So here, under solubility qualitative analysis, okay, so we have solubility of color, solubility and color. Yes, it's very, very important. Other section, you can see the first thing you see here is solubility and color. Then, is it a must that in WAEC that number two is a, my dear brother, yes, it's compulsory. In fact, that number two question is usually 21 marks in your practical. And if you don't understand it, then there is a big issue. So your chances of passing chemistry is usually very slim if you don't do well in chemistry practical. So we have tests of cations, tests of anions, tests of gases, tests for oxidizing and reducing agent. These are what we will be trying to achieve today. So what I'm going to do is that I'll run through the test, then I'll now take you to WAEC past questions, specifically GCE, because the one you do in normal school is very, very easy. So I need to give you the reason why we do all these chemistry practicals. All right. So let's say, for example, we start from a compound that you already know. Your normal. Okay, I think I have it in a slide. Yes. So here we have a analytical chemistry can be divided into three main parts. So you have qualitative, quantitative, then we have applied. These three are actually what I could ask you. Qualitative is what we are going to look at today. Quantitative is what we did last weekend and the previous Wednesday. Then applied is number three question that I could always give you. So here our focus is going to be on the qualitative aspect. So the qualitative analysis deals with the detection and identification of different substances, singly or in a mixture. So this part deals with anions and cations also. There are also identification of gases. So let's say, for example, if you have sodium chloride here, obviously, so we have sodium is an ion. Okay, so chloride is also an ion. So most time, if it is like a salt, now you know, sodium chloride is from a salt. It's from an acid and a base. So sodium is from the base part, while the chloride is from the acid part. So no big deal. So what we'll try to do is to carry out a chemical test to identify that there is a sodium there and there is also a chloride there. It's a very simple thing. It's a chemical test to identify that there is a sodium and there's the chloride that is present there. Okay, so that is what qualitative analysis is all about. So okay, so that's what qualitative analysis is, right? So I think I've already explained this. Now, first thing is physical observation. So it's always very important that you take note of this. I will send these notes to us in the WhatsApp platform at the end of the lesson as usual. So we have first things first, we have solubility tests. Now under the solubility test, all what we are going to be looking at, I want you to take note of this. A solubility of a salt can help us narrow down the possible identity of the salt. So in the exam, why I could not tell you that it's sodium chloride or it's ammonium carbonate, no, but from just the solubility, you will know the kind of salt it is. If immediately, the first test WAEC will always give you, unless they decide to change it, is to a sample of your salt. Perhaps you have seen it before. Or to a sample of the salt, add maybe 10 cm cube of water. So they want to do a solubility test for you. So the things that you need to know here is that if the salt is soluble, that means it could be a nitrate. You can see yourself all nitrates, hydrogen carbonate, sodium and potassium ammonium salt. Most, you see here, there's a quote here, most sulfates, most chlorides, most bromides, and a few, like very few hydroxides. So most time why do not even give a hydroxides. So they just give you, so the ones that are soluble are nitrate. Nitrate are usually very soluble. Chlorides are usually very soluble apart from some silver chloride. Then you also have ammonium salt, like ammonium sulfate, ammonium nitrate, ammonium carbonate. You see, the nitrates and hydrogen carbonate of these sodium, potassium, and ammonium are usually soluble. So that is where your thoughts come first. Then, so if you understand that, so let's see. Then if it is an insoluble salt, that means it's likely going to contain carbonates. Take note of it, most carbonates are usually insoluble and most hydroxide. So the ones that are soluble, the carbonates that are soluble are sodium carbonate, that's Na2CO3. Okay, let me just type it. So like you have Na2CO3. So this one is soluble. Okay, another one that is soluble is K2CO3. So it's also soluble. They have NH, ammonium soluble, NH4, close brackets, 2 CO3. So this one too is also, these are the ones that are very soluble. So these are the carbonates that are usually very soluble. So it's very, very important. You can see here. Then most of them are insoluble except these ones that I've written here. So barium sulfate, lead sulfate, calcium sulfate, silver sulfate, chloride, all these ones you can see here are what? Insoluble. So if WAEC is going to give you any test, they will not go beyond what I've written here. So you can have something like lead sulfate, calcium sulfate, silver chloride, lead chloride. These ones are the chlorides and iodides that are usually insoluble. Remember in the previous slide I said most chlorides are soluble, but these chlorides, silver, lead, they are usually what? Insoluble. So if WAEC now gives you ammonium chloride, that means you should always know that it is soluble. So when you have done that, I don't want to make you go too far. Or if you don't understand anything, use the chat section and simply type your question. Very, very important. Use the chat section and type the question. So if you are able to, if you don't understand, if I'm not clear, whatever I'm saying is not clear to you, please uh, don't forget. Okay, so let's push forward. Then we have the color of the salt can also help you narrow down the possible identity of salt. So immediately you see the salt sample that your teacher will give you in the exam. If it is white now, I at least I encourage you that how do they want us to identify them? Exactly, that's what we are going to. If it is a source now, so you can easily if it is WAEC, let's say 2020 WAEC now, the one that you be writing the next 1 month. Okay, so I'm going to have a special session. Yeah, that's a call. I'm going to call it a special session for that, uh, so that I can help you narrow it down. So that is very simple. So this is why I have to help you narrow it down, because you guys have been very, very good and very interesting. So, but the ones that WAEC will always help you. Now, if you call salt appears blue, just tell your mind that it's going to be a copper salt. If it's looking green, can I see there is these two type of green here. You can see this type of, see, look at my two types of green. Maybe you see this kind of pale green is iron 2, but if it is deep green, that's physical observation. Okay, so if the salt looks reddish brown, automatically in your mind it's only likely going to be an iron 3 salt. That it could also be a copper metal, but why I could tell you that sample is a mixture of salt. So immediately is a salt, that means you eliminate copper. It's as simple as that. If it is gray, so it's going to be metal. So, but nobody gives you metal. Okay, so if it is black, you have metal oxide, sulfide. So copper 2 oxide, take note of this one. Copper 2 oxide is usually black, and copper sulfide too is also black. So your job is for you to find out which of them it is by the next things we are going to be discussing. So, all right. So, next thing we move on is action of heat. Now, the reason why I'm taking this part is because the third question that you always see in WAEC, that number 3, even me, as good as I am, I can never predict it. As good as I am, I can never predict it. The reason why I cannot predict it is because I'm not the one that said the question. So if I was the one that said the question here, I can easily tell you that, oh, she, I said, okay, blah, 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 blah. But here, you cannot predict that third question. So this aspect is what you're going to help you to understand that third session. So here, there are different questions they can ask you. Action of it, we don't do this anymore. In those days, they usually do it. But nowadays, they don't do it anymore. And the reason is because heating procedure, the demand for um, safety safety for students is higher now. Like those days where they just tell that you hit a substance, and most time you don't have nose mask or like we have now, uh, goggles to protect your eye. So, but nowadays they've reduced the extent to which students actually do direct hitting. Okay, so but here you still have to know it. So on heating, you need to observe change in color, change in state, if it's changing from solid to gas, or if it is going to be melting. If there is going to be a effervescence, okay, so you have to test for the gas. Remember, WAEC will never tell you to test for the gas. So the color changes involved and the gases liberated will give us the identity of the cations and anions present. So this is what we are going to run quickly to. Look at this one. Take note. Initially, it was a white solid, but on heating, it became yellow. On cooling, it comes back to white. So that means it's likely going to be what? Zinc. So that kind of compound, you can have something like zinc oxide. Initially, it was white, but when you heated it, it became yellow. Then when you allowed it to cool, it became white again. Then what happened there? That compound is likely going to be what? Zinc oxide. Okay, so it's very, very important. And most of the time, how do we start the heating? So I can just give you zinc carbonate, ZnCO3. When on heating, it now becomes it now has like zinc oxide. So during the process of heating, it's usually yellow. Then obviously you are going to liberate CO2. So the carbon 4 oxide will escape. Very important that you remember that. So that's why they said you can test for the gas. So whenever there's this kind of heating, you must take note. It's very, very careful because about for this 2020 vehicle, if it's going to be like this, will I tell you? Yes, if you keep in touch. So I will definitely. Now another thing you need to also know that is common is lead. Lead white on heating it becomes orange. So people say I don't say brown. It becomes orange in color. No, some people say brown. Yes, some people just say brown. But it's very, very close. But when you cool it, it becomes yellow. Can you imagine that kind of then lead salts are so the reason why is it like that? Because lead salts are usually white. White. Let's say you have lead carbonate. Take note of it. Lead carbonate now is going to be white in color now. Lead 2 carbonate. So when you heat it, obviously it's going to give you an orange color. This is lead oxide when it is hot. So when you're liberating carbon dioxide, so CO2 is also liberated. But you can only test for the gas cannot come back. But when you cool it, it still remains lead oxide by itself. So when it is lead oxide is usually orange when hot, yellow when you cool it. So it's also very, very important that you remember uh, this aspect of it. So most of the time it's usually rapid. These observations are usually rapid. So the teacher should be able to tell you if it is the kind of salt that is coming out in while. So sometimes we talk about gas liberated too. In what cases will you liberate a gas? So these are some chemical equation you must be able to know that this one there will always be carbon dioxide. Whenever I hear that is a carbonate, you know what I mean by a carbonate, like CO, like CaCO3. So it contains a triazocarbonate, or sometimes, yeah, let me just say carbonate. Most cases, most cases is if it's a carbonate, obviously carbon dioxide will be liberated. So, or when it's a combustion of organic compounds, so that's very easy. So, how do we know that it's going to be hydrogen that is produced? Take note, if it is a carbonate, that means you're only going to get the carbon dioxide. Just treat this one like this with HCl. This is very simple. Whenever you treat a carbonate with HCl or any kind of acid, we are still coming to it, you obviously observe that a gas will be involved. But if it is a metal, anytime you hear a metal and an acid, whether it's an organic acid or an inorganic acid, hydrogen will always what come out. So take note of that. Whenever so it's very, very important that you try and remember that if it's a metal and acid, whether organic acid or inorganic acid, hydrogen will be discharged. So it's very, very important. Now, how do I know that it's oxygen? Take note. Nitrates or oxides of less reactive metals. You know what I mean? Less reactive metals. Something like PbNO3. You know this kind of compound. PbNO3. These ones are less reactive. Lead. CuNO3. If you are going to heat it directly, you see these are very metals that have less reactivity. So when you heat them, when you carry out the reaction and they produce a gas, just know that that oxygen is going to be what? The gas is going to be likely going to be oxygen if it is a colorless gas. So it's always very important to know the physical nature of the gases. Then obviously when it is a hydrogen peroxide, that's H2O2. So I know you are warming up for this kind of, but this hydrogen peroxide, please, I'm asterisking it for 2020 why. Don't ask me why. Just study it again. Okay, so let me just, if you hit it, so it will always give you H2O and oxygen. So that is, so if you expose hydrogen peroxide to air, it undergoes decomposition, though it's slow. So it's one of the method of producing oxygen in the lab. Okay, so very, very important for you to remember all these things. Okay, so that is, I quickly want to go to the real stuff now. Whenever there's ammonium salts, they are obviously going to get ammonia. Obviously. Okay, so but why don't always expect us? Why can I ask you to do a test for ammonia? We are going to look at that. Then chlorides. We always look at chlorides, then sulfites and sulfates. So this is this is very, very important that you remember, you know the difference. When you say sulfite, it has something to do like SO3. So if it's sulfite, SO3, 2 minus. So if it is sulfate, I have SO4, 2 minus. Can you see the difference between sulfite and sulfate? So it's very, very important. Sulfite will always give up carbon dioxide, but sulfate don't give off carbon dioxide. This is very, very important. Let me take that again. Sulfites will always give off sulfur 4 oxide when you are treating it with an acid. Or or maybe another reducing agent or oxidizing agent. Okay, so another oxidizing agent. So it's very, very important. So always take note. But sulfates will never give off sulfur dioxide. That's SO2. So take note of that, of this gas. So we're going to learn how to identify these gases very, very soon. Okay, so now here we are. Okay, so here we are. This is the core. This is the core of the, call it, practicals in WAEC. Like I said at the beginning of here, that every salt. Okay, Ayomide, you can unmute yourself and ask question.
So I did not hear the differences between the sulfates and the sulfites very well.
Okay, so very important. Okay, thank you very much. You said you couldn't get the difference between sulfates and sulfite. All right, so let me explain again. Now, first of all, sulfite is SO3, 2 minus. Now, this any salt that contain example of such salt that cause sulfite is the Na2SO3. So you can call it sodium sulfite. That's the old name. But if it is a sulfate, it must contain SO4, 2 minus. Okay, so that's a sulfate. Like, yeah, you now have Na2SO4. So both of them don't usually, there are different ways to identify chemically if it is a sulfate or if it is a sulfite, and we are going to look at it right here and now. Okay, so I don't want us to carry over this topic till Saturday, but if time does not permit us, I don't mind. But definitely, I want us to go a long way because WAEC is knocking on our door. So here at the beginning of the lesson, I talked about salts containing two type of ions. One is positively charged and one is negatively charged. So how do we identify the cations? So those cations are positively charged. So take note of these ones I'm going to list. It's ones like copper. Copper is +2. Okay. We have copper. We have calcium 2 plus. Calcium 2 plus. Then we have zinc. Zn 2 plus. Okay, very, very important. So we have aluminium, iron 2, iron 3, then ammonium. So these are the major ones that WAEC will always, let me just write A 3 plus. These are the ones that WAEC will ask you. Again, we have Fe, iron 2 plus, Fe2 plus, then Fe3 plus. Then finally, because we talk about the ones that WAEC will ask you to study. So these are the ones that WAEC will always ask you. So obviously then we now include, let me include this copper here so that you can always remember. So these are the key ones that WAEC will always tell you to identify. Okay, so if you're able to learn about them, then you are good to go. Okay, let me bring it down here. Now, how do we identify all these cations? Remember, initially I told you about the beginning. If it is blue, if you focus your mind on copper, immediately the salt that your teacher gives you is blue. Don't come and be saying is calcium, is zinc, is aluminum. For God's sake. Unless Wagner says sample C is a mixture. You see, when it's a mixture, that means they must have mixed two salts. When it's a mixture, that means is that going to be one is colored, one is colored, the other one is colorless, or both of them are colorless. So very, very important that you have to take note. But if you say C is a simple salt, automatically focus your attention on the color. If they say is a mixture, don't kill yourself thinking about the mixture. Okay, so but that's very, very important. So immediately say it's a simple so that's when you can easily say, thank God I know this one. But if it's a mixture, don't rush. Okay, so it's very, very important that let me answer this question. All right, so this is our okay, no problem. Somebody's requesting for something, no problem. I will definitely do that. I'm free tomorrow morning, so we can talk about that. All right. Um, so here we have sodium hydro. So to identify the cations, so we have to use two compounds to identify our cations. Usually you see sodium hydroxide in drops and in excess. Can you remember that statement? Or you can hear of aqueous ammonia in drops and then in excess. So it's very, very important. So here we want to observe very simple thing. Observe for the presence of a precipitate and note its color. Then solubility. I'm not going to say beyond that. Observe the what? The precipitate. You know why I say precipitate? A lot of students usually struggle. What is different? What can I use to know a precipitate? Immediately you pour powdered milk inside a cup of water. What color do you see? Cloudy situation. Yes. So that's what we call a precipitate. Very, very simple. So sometimes that cloudy situation, after about a minute, if the glass cup is clear, after not a minute, if about 3 4 minutes, if the glass cup is clear, if all this milk dissolves, you see here that some of the milk went to settle at the base of the glass cup. That is why I say is an insoluble precipitate. But if everything is clear, if everything dissolves like liquid milk, then you obviously will not see any precipitate. So that's why I say is a soluble precipitate. You have what we call soluble precipitate and an insoluble precipitate. So sometimes the precipitates are usually soluble, and most time for the one that WAEC gives you, whenever they want to give you a soluble precipitate, it will end up becoming clear. You know what I mean? Clear. You can see through. That's why I say it's the one that WAEC will always give you so as to avoid ambiguity. So WAEC will not say it's still will not come and be writing is a soluble precipitate after 10 minutes. No, 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 we don't do that kind of thing. If it's soluble, it's soluble. If it's insoluble, it is insoluble. So that is what WAEC does. Okay, so to identify the cation, we use sodium hydroxide and what? Ammonia in drops and then in excess. So these are the various sorts and how they behave with. Now, I'm going to be telling you what I have done here. I try to streamline everything because why I cannot give you everything. It's not true, my brothers and my sisters. Why I cannot give you everything to work on. Okay, so it's very, very important. I think I forgot to put calcium, copper. So perhaps in my okay, yeah, okay, so okay, so I have calcium. So calcium now why I could always tell you to after you have dissolved it in water, divide into 3 portions using your test tube. To the first portion, add sodium hydroxide in drops and in excess. That shows here that they want you to identify the cation. Immediately you see to the first portion, add sodium hydroxide, they want you to identify the cation. If they now say to the second portion, add aqueous ammonia in drops and excess, that means they want to confirm that what you have is actually what you have reported. Now, if it is calcium, at the beginning, when you add it into the sodium hydroxide, you will not, you see white precipitate, insoluble. This I here means insoluble. Please take note of this. White precipitate, insoluble. I've seen students, they will see, it's just like when you take a salt, what I call it, sugar. Yeah, you take 1 big spoon of sugar and put inside 1 glass cup of water, and it dissolves. That is what we mean. So for zinc iron, look at what happens. This ones, this is how this is what happens. It's like taking a spoon of sugar and pour it inside water. It is soluble. Take note. So that is immediately you can see all of them are the same thing. White soluble, white soluble, white soluble. So that is why whenever you do your test, you do your observation, then you do your inference. Pardon me, you will not say white precipitate soluble in excess. Then you always see on that table they will write uh, Zn 2 plus, then I put comma, and I put Pb 2 plus, then I put Al 2 plus. The reason why they have Al 3 plus, the reason why they have to put all of them together on that first line is because when they test you with sodium hydroxide, all of them usually give the same thing. So we are not sure which one. Take note, because we are not sure which one. So that's why we have to write the three of them. So to confirm whether it's zinc or whether it's lead or whether it is what? Aluminum, we have to carry out the further test by taking the second portion and adding ammonia in drops and then in excess. Adding ammonia in drops and then in excess. That's so when you add ammonia in drops and excess, if it dissolves again, fine, God bless you, you are happy. So that means you will no longer report about lead, or whether will you report about what? Aluminum. You will only report about zinc. So you now write that second Zn2 plus present. I've seen it's in the past, as I'm marking both WAEC and my normal schoolwork, I would say a student in the first test, why precipitate soluble in excess, the person will write zinc, lead, and aluminum. And they'll now come and add the second portion, they now add ammonia. And the child will now be saying, I did not say anything. Obviously, you did not say anything because it's soluble. Then the child will now come and write calcium. For the love of God, how can you confirm calcium? In the first sentence, you never talked about calcium. Now you are confirming calcium. That is totally very strange. You cannot confirm calcium, and that means your answer is very wrong. So please, it is a continuation of what you have on sodium test with sodium that you confirm. What do you call it? With ammonia. I've seen a situation where a student, after observing that he gave you a green precipitate and it was insoluble, after a student have written insoluble and he wrote iron 2, when they tested with ammonia, I don't know what will happen. The child will now go and be confirming lead. Is it possible for you to observe iron 2 in test with sodium hydroxide? I am not confirming again. You now leave iron 2, you now can be confirming iron 3. I just don't know where a student will get that from. As long as it is green, it will still your the ammonia test is just a confirmation that what you wrote in the first line is actually what is in this second line. You're only confirming it. So you cannot write, if you write iron 2 plus, that means you should also write iron 2 plus in the second one when you're testing with ammonia. It cannot be iron 2 in the first sentence, then in the second one, automatically you will now have error. Even if you have error, please don't ignore me, ignore your teacher. Write it as iron 2 plus. Immediately the first one gives you a green precipitate insoluble. And you already know that iron will also be green precipitate insoluble in ammonia. Don't bother saying, I observed that the iron 2 was insoluble in ammonia, or was soluble in ammonia. How can you say that kind of thing? First of all, study this table and write exactly what you know. So what if we have, this is a question, so what if we have lead 2 plus and aluminum 3 plus? What is the confirmatory test to differentiate between the sort? Very simple. Now, it's because we are not in the lab. What we do here, if when you get to a lab situation, please, before I do that explanation, we have two sessions as usual. In the next 1 minute, we'll end our first session. So you log out and log in again. Okay, so because the first session is usually 40 minutes and the second session is 20 minutes, and we don't want to stress you beyond that. So now, there are different kind of whites. Let me ask you a question. You know, your gari is white, your chalk is white, and your sugar is white. Now you now take your sugar is soluble in water, fine. Your chalk, okay, let me even use pap. Let me use pap, or custard is sometimes white. So um um when you add custard inside water, it will still give you white precipitate. If you add garri, it will still give you white precipitate. But you find the nature or the texture of the precipitate is different. If it is lead, it's usually powdery. Powder, as if you pour powder inside water. So when you get home today, or when you are done with the lesson, take powder and pour it inside water. You see the way lead behaves. It usually have a powdery precipitate. It's powdery. Meanwhile, for aluminum, it will look as if it's creamy. Like when you put your cream inside water. So it usually look as if it's creamy. So, gentlemen and ladies, The first session is over, and I wouldn't want anything to interrupt the second session, so that time will just we maximize our time. So let's log out now, and